This is for year 11 methods, ex3L question 3. Okay, so we've got an equation relating the efficiency of a spark plug with the gap in which the spark plug is set, and that's in x millimeters. So if I write the equation down, we've got E equals 400 x minus x squared. Now, this isn't fully factorized because we can still take a common factor of x out. Now in this form we can read directly what the x-intercepts are. They'll be 0 and they'll be at 1. Now if I draw the graph, it says it's drawn between x is 0 and 1, which makes sense. That's actually where our x-intercepts are at. So E versus x, and we know that the x-intercepts are 0 and 1. So if I draw a graph, it'll look something like this. The maximum, because this is a parabola, the maximum will occur at 0.5 because it's halfway between the two x-intercepts. And we know this is a positive parabola, negative parabola, because x times negative x is negative x squared. So the coefficient of the x squared term will be negative, which is why it's upside down. We have a maximum. So the maximum will occur at 0.5. Now to complete the graph, I would actually find out what the actual maximum is, and I can do that by just subbing in 0.5 into the equation. 5 1 minus 0.5, and I get 100, which makes sense. That corresponds to 100% efficiency. So we sketched the graph, we found the x value which gives us the maximum efficiencies, which is 0.5. And what value of x gives the maximum? What values of x give 0 efficiency? Sorry, for part B, what values give 0 efficiency rating? So we know this is 0 here along this line. So the values of 0 and x equals 0, x equals 1 gives you the 0 efficiency rating, while x equals 0.5 gives you the maximum efficiency rating. Use the graph otherwise. Determine the values between which the efficiency is 70 or more. Okay, so I can do this graphically. When I sketch the graph of the equation, I can see when it is above 70 or more. X. So I can I'll first press graph, then I drag this on. Now, here we've got a perfect view of the graph. You'll need to know how to adjust the view by changing the x min and x max and y min and y max value. That's not difficult considering we know roughly what the graph is. So we know the x values automatically lie between 0 and 1. The y values would lie somewhere between 0 to 100. So you can go 0 to 150 just in case it doesn't work. So in this case, our graph is perfectly aligned. Now we want to find out where it intersects with 70 or more. So I'm going to put 70 here and drag it down. So it draws a line of 70. I need to re-highlight my other graph and put it on as well. We need to find where they intersect, because this is the 70 line, and we want it to be, which is an efficiency rating of 70 or more. So I just need to find the analysis, gsolve intersect, and we got 0.23 and 0.77, 0.23 and 0.77. So it is between 70 and more when the x value is between 0.23 and 0.77. So graphically I can draw it like this. We want to find when it intersects with 70, and it happens to be with 0.23 and 0.77. And it includes those points because it's either 70 or more. Now we can solve this algebraically if we want. So if I drag this down, we want to make that equal to 70, we go interactive, advance, solve. Oops, interactive, advance, solve, and we're solving for x. And for some reason I put a 70 there. So let's do this again. Execute, and we got 0.23 and 0.77. But if you do it using the algebraic way on the calculator, make sure you know what the graph looks like. Otherwise, you're not going to choose the right regions, because you want to choose the region above, not the region below. Hopefully that helps.